IBM and University of Melbourne present seizure prediction system. Researchers from IBM and the University of Melbourne have developed a proof-of-concept seizure forecasting system that predicted an average of 69% of seizures across 10 epilepsy patients in a dataset. The system, which the scientists claim is fully automated, patient-specific, and tunable to an individual's needs, uses a combination of deep learning algorithms and a low-power brain-inspired computing chip to predict when seizures might occur, even if patients have no previous prediction indicators. For the proof of concept, the researchers borrowed 60 days of data per patient from an earlier study conducted by the University of Melbourne and St. Vincent's Hospital, achieving a 69% average prediction rate despite the algorithm having no knowledge of future data. This allowed the researchers to simulate how the system could operate in real-world scenarios, and the algorithms were retrained in response to an individual's long-term brain signal changes. To date, much of the research has been limited to training algorithms based on general patterns for seizures. For example, doctors manually selected signs and patterns which could preempt seizures, which were then used to train prediction algorithms. However, these researchers were limited in their ability to reliably predict seizures across all patients in a long-term fashion, given brain activity patterns are not only specific to an individual but also change over time. The epileptic seizure prediction using big data and deep learning, toward a mobile system report states. New deep learning techniques have helped us improve from previous results, allowing the system to automatically identify seizure patterns for individual patients and adapt to changing brain signals over time, without additional human involvement. The seizure prediction system, which was designed to be adjustable to when and how an epilepsy patient would prefer to be alerted of an upcoming seizure, was deployed on an ultra-low-power neuromorphic computing chip to demonstrate potential applicability in the real world as a smart wearable. Epilepsy manifests itself uniquely in each patient, meaning insight into brain patterns and signs which may preempt seizures is not a one-size-fits-all approach. However, with the advent of new artificial intelligence technology which can automatically analyze data and pinpoint tiny signs that preempt seizures, this idea of personalized medicine is now becoming a possibility, IBM said in an announcement. According to Epilepsy Action Australia, more than 65 million people worldwide are living with epilepsy, making it one of the most common neurological conditions. In Australia, 250,000 people have been diagnosed with epilepsy, with 3% to 3.5% of the population expected to experience the condition at some point in their lives. While anticonvulsant medications can be administered at sufficiently high doses to prevent seizures, 1/3 of epilepsy patients do not respond to available treatment. In addition, due to the spontaneity of seizures, epilepsy patients have restrictions around activities such as driving a car, and live in fear and uncertainty about when the next seizure will occur. The scientists involved in the development of the proof of concept said the research moved us beyond the restrictions of conventional machine learning, towards a deep learning system which has the potential to offer greater insight for medical decision-makers in epilepsy management and treatment. IBM is not the only organization to explore the combination of machine learning and wearable devices for epilepsy management. A UK initiative last year, called MyCarecentric, brought together wearable technologies, shared care records, machine learning, and data analysis tools to assist epilepsy patients with monitoring their condition. An app was created to collect information such as sleep patterns, exercise, heart rate, temperature, and galvanic skin response from devices such as the Microsoft Band and smartphones, and then integrated with a patient's clinical record to predict when a seizure might occur. IBM also revealed earlier this year how its cognitive computing facilities were being put to use in the fight against eye disease. By using deep learning and visual analytics, IBM researchers were able to quickly diagnose and classify diabetic retinopathy in patients without the need for extensive tests. IBM, Pivotal collaborate on tools for app development. The collaboration gives developers more tools for streamlined app development and more options for deployment in different clouds. IBM rolls out first Power 9 servers, Systems optimized for IBM's AC922 power systems embed PCI Express, NVIDIA's NVLink 2.0, and OpenCopy. IBM outlines 50-qubit quantum computing prototype. IBM continues to make strides in its effort to commercialize quantum computing. How IBM's Quad9 service protects users from accessing malicious websites. Tech Republic. The company says the new DNS service will block visits to harmful sites while protecting users' privacy. IBM Watson digs deep on data to pave the way for enterprise apps. Tech Republic. IBM has expanded the functionality of its Watson data platform to include data cataloging and data refining, to help developers and data scientists